Welcome all. Well, it's very great to see you all here, and it's great that you all came to my talk about domain-driven design and clean code. Two subjects I'm very passionate about, so I hope you all enjoy it. Let's have a see. All right. What I'm going to talk about first, what is domain-driven design for the people unfamiliar with it. Then I'm going to cover 3 themes of domain-driven design: the ubiquitous language, supple design, and the bounded context. And at the end, I'll talk about what's next. Now we know all this. So personally, my domain-driven design journey started at Beer Central at DevOps. After a long day of conference, we were talking about the talks we liked the most. And I was really a fan of the talk Refactoring to a System of Systems from Oliver Drotbaum. It was a talk about moving from a monolith to microservices. And some of my friends said, this talk uses a lot of DDD concepts. And I was thinking, DDD, domain-driven design, I never heard of it. But I was curious, I want to know more of it. And after all, I noticed that it wasn't the only talk about domain-driven design and microservices. It became increasingly popular with microservices, mainly because of the book of Sam Newman, Building Microservices, which mentioned domain-driven design, and especially the bounded context, as one of the key concepts for partitioning a larger system into smaller parts. And since that moment, domain-driven design became more mainstream, but however, it's still often misunderstood. So what is domain-driven design? It came from a blue book written by Eric Evans, and it's already quite old. But if you read it, you'll notice that most of the core concepts still stand. So what did I do? I bought the book, and I thought, let's read it. But it was quite a big book, around 700 pages, and it wasn't an easy read, very slow progress, and at the end, I stopped halfway. And then later that year, I went to a job interview, and there the technical coach, who I chatted with, asked me questions like, do you know anything about tell, don't ask, or an anemic domain model, which were new to me, or how do you split up a bigger system into smaller parts? Well, at the end, the advice came that I might want to dive into domain-driven design. I was pretty enthusiastic about how clean my code was, but still, this might be a thing for me to dive into. So I went back to the blue book, with some little more determination, and this time I finished it. It has lots of wisdom in it, but it didn't all stick. So for people who are new to domain-driven design and want to know more, I would suggest another path. Alberto Brandolini, he wrote a blog post about domain-driven design in 2020 for people new to domain-driven design to get a grasp of what it is about. And it is not an architecture or a method, but you can see it as an approach to software development with some key aspects. And one of them is focus on learning. So the idea behind that is that the bottleneck of writing great software is that you have to know the solution and the problem domain very well. If you don't know that, you're not able to write the good code. Another one is that language is a first-class citizen, so language is very important, and that multiple models are key for not evolving into a big ball of mud. And that's where the bounded context comes into place. Moreover, good coding practices are expected, which is also related to the focus on learning. So if you have new insights every time, then you should have great test coverage, for instance. Otherwise, you won't be able to refactor your system into all your new learnings and to change it the way you think is now appropriate. And last but not least, you should know your core domain. So what is the most important thing you are building within your company? That's probably where you should spend the most time and put all this effort in, but the lesser important parts might not be worth it to go full-fledged domain-driven design. And so if you want to know more about this, this is just the tip of the iceberg, but go ahead and read the blog post, and don't start with the blue book, but start maybe with the red book, Implementing Domain-Driven Design, or the Patterns, Principles, and Practices book. Those are way more accessible. Okay, so now I'm going to tell you how domain-driven design made my code cleaner and the journey I have been through. But first, who am I? My name is Paul van der Slot. I'm a freelance software engineer at Alliander at the moment. And I'm a big fan of practices like domain-driven design and clean code. And this is a picture of me with my girlfriend and my son in a boat in Rotterdam. So on to the ubiquitous language. What you often see is that a domain expert and a developer are talking, and that a domain expert says a word, in this case, cargo. But the developer knows, yeah, that's not how it worked in the code. That is something else. We have a shipment in the code, and maybe the relationships with the cargo and something else are also different in the code. So what happens is that in the head of the software developer, there is a translation between the conversation and what is actually inside the code base. And this might lead to misunderstandings and also not the ability to fully cooperate and collaborate towards a solution with the business consultant, with the domain expert. So you see that the mental models are different for the domain expert and the developer. And the idea behind the ubiquitous language is that you have a shared model, not only between the developer and the domain expert, but also within the code base, within test scenarios, within the Scrum team, user stories. And everyone speaks and thinks in that model. Ubiquitous means everywhere. But it cannot be everywhere, so therefore it is specific for a domain. It's everywhere inside that domain. So an example there is, for instance, a product in e-commerce. In the domain of shipping, it might mean something that needs to be delivered, but in the domain of a catalog, a product might mean something different, something that needs to be displayed or something you can buy. So that's the same word with always the same meaning within a context, but a different meaning on another context. So this is what you want. The same model for the domain expert and the same model for the one who codes, so that you can collaborate easily. But how to do that? The subtitle of the Blue Book is Tackling Complexity in the Heart of Software, and the idea behind that is that the complexity of software is within the business. Solving the business problem is really the complex thing that you want to tackle. And that should be central in your solving, in your code and in your solution. But that's hard, it's often cluttered. So what you see here is the brown pieces, a database, a REST call. They come into your code and they clutter the view. So it isn't totally the same. What you would want is that domain logic and the business problem are matching, and that you can separate those brown technical details from your blue model. And at the end, that would mean that you have as little as accidental complexity as possible in your domain. Well, one way you can do that is with using a hexagonal architecture. It's first mentioned by Alistair Cockburn, and the idea behind that is that you have your business logic central in your code base, and that all the details are on the outside. The idea behind that is that a change of your REST API or a change of a database doesn't impact your business logic. So your business logic is independent of all the details on the outside. And that means that if you, for instance, need to switch a database, your business logic shouldn't evolve. It should only evolve because of a change in business. Well, it might seem a little bit abstract, so I have a code example in Java. In this example, there is a card service. I hope it's big enough so you can see it. There is a method in there, activate cards. And first, you get some card details via a REST client. You get some cards from the database. And you see there that it is with a REST model and a database model. And after that, you will activate the cards. You probably have to do some validation or some transformation, some null checks, and then the business logic at the end. And then you can save the updated cards. But this isn't exactly what we talked about. You see in this detail, it's cluttered with all these details. So how would it look like if it was more hexagonal? Now they are next to each other. So on the right, the hexagonal example. And you see there that there is a card, a domain entity arised. So we find all the cards through the repository, and we activate them. And there's only business logic in the activate cards. And then we can update them. So all the details are gone. And now you can think, how did that happen? How did all the details go away? There is an interface introduced, a repository, and it is talking in terms of a card ID or a card in business objects. And with the dependency inversion principle, this interface is implemented in an adapter outside the business logic where all the details are happening. So there is the validation, the null check, and the transformation, and the gathering of all the data, so that the domain can stay pure. So if you, for instance, decide that you need to get your card details from somewhere else to do another REST call, it will not affect everything above the white line at all. That will no impact there. So that's what I was talking about. All right, so we want our model to be the same as the code. How can we do that? A famous phrase in domain-driven design is also make the implicit explicit. So one way to do that is to stop using strings everywhere. It is often called as stringly typed objects or primitive obsession, where everything is a string or an integer. But what you can do as well is introduce value objects. So what is a value object? A value object is an immutable type that is distinguishable only by the state of its properties. Examples of value objects are, for instance, money or height or color. And what you can do with these value objects, you can create new types, new objects, to make your code more explicit. Okay, how does this look? If you want more information about this topic, I suggest you Google Denver Johnson with The Power of Value. He has a great topic about value objects, and he refactors the whole code base introducing value objects to make it very explicit. But I have an example here as well. So if you check in a hotel, for instance, you have a room number. And you can validate if the room number is positive, and then determine the floor, and maybe at that moment you want to validate again because other people can determine the floor as well. You can call that method as well. And then you do the logic. So there's quite some noise inside of this example. But what if you introduced a value object, room number? What is the case in this example is that now inside room number you can put the validation. So a room number is implicitly always positive. So there's no need for the validation anymore. You can also limit the operations to useful ones. So when it was an integer, you could add room numbers. So one room number plus another room number. That's not very useful. And as well, you have now a place to put your logic. So the get floor now has a home. You don't need to have a method somewhere, but you can ask the room number to get the floor for you. And in this way, it becomes more clean. So what I have noticed is that value objects may act as a center of gravity for complex business logic. So if you can put this, for instance, the determination of a floor inside a room number, it has a home. And in that case, it's also immutable because it's a value object and easy to test. So you don't have to test all these separate methods, but you have just objects with a purpose. And you can think, okay, this duplication, I can also fix that with utility methods, for instance. So in this example, I will be talking about email validation. It is duplicated all around the code base. In different parts, there is email validation. So how to remove this duplication? The first option is to put it into a utility class. So you can make something like this, email util.matches pattern. And every time you want to do this, you need to call the util method to validate. But the problem there is you need to know that it exists. So you often see people still implementing their own implementation of the pattern matching. And if you're later on in the code, you don't know if it's validated already. That's also a problem. If you create a value object, so you create an email object, you will use the validated email everywhere because the validation is inside the email. You can also use the email type as a parameter, so you force that people have the validated email at the moment they start using your code, and you introduce some explicit domain meaning. So I think that's the better option of the two that I proposed. Okay, so if you want to do this tomorrow at your work, how to start? Well, you can start talking with your team and introduce a ubiquitous language. What kind of words are there in our domain that have meaning? And if you learn new concepts, you can just introduce them into the code and start going from there. And at one moment, you will see that the current understanding that you have of the domain is reflected inside the code. And it becomes even more powerful if you also turn it around. So if you make a change in the code base because you need, for some reason, then you can verify with the business, okay, our model changed this way. This is now our new view. Is that correct? And then you can interact with the business in solving the solution. And of course, this is an iterative process. So you can just start with it and you can continue to do so forever. Okay, another important topic or concept to stay close to the ubiquitous language is tell, don't ask. It's also something to help you to reduce coupling. But what does it mean? The idea behind this is that you should tell an object what to do instead of asking for internal data to do the job yourself. And if you think like this invites you to add behavior in the object close to where the data is. Okay, so this might be still a little bit abstract, so an example again. And in this example, you see that there's a lot of asking. So card, give me your account to see if it's blocked. Card, give me your owner to see if I can trust him. But if you think about it, at the end, you want only data from the card to determine if it can be activated. Maybe you should just say to the card, hey, determine for yourself if you can be activated. And then in other places, when they want to do that as well, it reduces duplication, and you now have a clear business meaning in your method. So this is the key concept behind tell, don't ask. And very related to that is the phrase from Alan Holub, getters and setters are evil. So a small example about that one as well. So where on the top left, you see a lot of setters. So you set a shot type, a dose, and a nurse, while on the right, you obtain a vaccine and you give that flu vaccine to a patient, which is, way more describing what actually is happening. The problem with the setters as well is that you can forget to call one. You can, for instance, set the shot type, set the nurse, but forget to set the dose. There is no really explicitness about which combinations are allowed in this case. And the getter example we just talked over, like getting the owner, while you can just ask the card to if it can be activated. And what I have noticed is that for setters, I haven't seen a very good example except of ORM frameworks that require them. It probably is better to name those actions concretely to what the business is doing, and that most of the time it's not something with set. For getters, there is of course a place, but I think you should always ask yourself, do I really need this information outside the object, or am I actually trying to do something else? So my advice would be don't auto-generate getters and setters and think twice before you introduce them. Yeah. All right, so now on to Supple Design. What do I mean with Supple Design? Supple, you can see as the opposite of stiff. So what most people think about is then it's loosely coupled, highly cohesive, and you're able to change your code easily. And there are also some patterns and heuristics in the domain-driven design book on Supple Design. But first, I want to elaborate a bit about coupling and cohesion, because to me, it often seems as a phrase that we blurt out in meetings too often without really understanding it or thinking about it. So if you think about coupling and cohesion, you can see it as coupling, tying things together, and cohesion, things that stick together by itself. So first, coupling. Coupling has to do with change. So if you see coupling as a function of A, B, and change, it means that if A changes, B has to change as well for the total correctness of the system. If that's the case, then A and B are coupled. And that can be on different levels. So you can see a blue circle as a class or a microservice. And on the left, you see tight coupling, a lot of lines going in between the circles, and on the right, more loosely coupled. But you can only count the number of lines in between the bullets. So in the left, you see a piece of code where the gross price is get from the item, and the tax rate as well, to calculate the net price by yourself. While on the right, you just ask the item, compute the net price for me, and then the item talks with the tax rate by himself. And this is also an example of tell, don't ask, by the way, and encapsulation. And if you want to know more about levels of coupling, it might be interesting to look into TEQnation. There's a lot written about that and about the degree of coupling that you can have between objects, between classes, between microservices. Okay, cohesion. So that's the other part, stick together. And what it basically means is that when one thing changes, everything has to change. And you can think of that as something bad. Like, if you think about it, what is the alternative? If you have everything close to each other and one thing change, then that means that everything has to change. It would be way worse if that was distributed all around your system. So it is actually nice that it's all located close to each other. And a great quote about that is, attempting to divide a cohesive class would only result in increased coupling and decreased readability. So at the example here, the high cohesion one is with all kind of lines in between them, and the right one, you could say, should maybe be divided in 3 parts. There probably isn't a single responsibility in the right example, because there are 3 different things that are going on there. And that's also what you see, that cohesion has a lot to do with single responsibility and separation of concerns. And if you want to know for sure if a class is cohesive, my advice would be follow the commits, look in your commit history, and see if, when changes are done to that class, what is changed together. And if you see that it's always the same parts, then there might be a good indication to split up that class in some part. So low coupling and high cohesion usually has an effect on software that it's easier to test, that it's easier to maintain, and easier to reuse. That part is from the cohesion. If a unit is cohesive, then it has a single responsibility and it's easier to reuse. And one of the other great benefits is that the blast radius decreases, the impact of change decreases. So changes are very isolated. Okay, so far for cohesion and coupling. Back to the blue book. There were some heuristics and patterns to get to supple design in that book, and I will discuss 2 of them. One of them is intention revealing interfaces. So when a method name isn't clear, you have to look inside that method to see what it is doing. And you might go down the rabbit hole if inside that method is another method which isn't clear, and so on, and so on, and so on. So how to fix that? Yeah, you probably want to use cohesion, so group things together that belong together. In that way, it probably has a single responsibility, and naming should be easier. And then name things very well. Well, that's easier said than done. So in this example, we have a chef who prepares a string. Yeah, well, I am quite likely to click on that on that method and have a look what is happening inside there. While if the chef is making a dish, it might be more obvious what is going on, and you might not have the intention to click inside the details and go on. So try to name things, although it's hard. And if you have a problem with that, try to use the ubiquitous language and the talk of the domain to help you name things. There might be already a great name for what you are doing. The second one is side effect-free functions. There's a code snippet in here. Calculate price details, and you can have a look if you think it's full of side effects or not. Well, first, the price details are determined. Then the total order price is added by those price details. The price details are added to the total order price, and then it's returned. So you have probably noticed at least one, and that is the total order price. So every time you calculate the price, it is added to a list, to a collection. But there's also a subtle other one, which is the tax rate. If the tax rate changes, the result of the calculate price details changes as well. So there are 2 ways that you can have side effects. One of them is side causes, and the other one is side effects. So the tax rate you can see as a side cause. It is like something external that influences the effect of the function. And the side effects is something external that is happening after the function is called. And the preferred way is that you only have the green arrows. So you have arguments, you have a return value, and the function inside, which is very easy to reason about. There's nothing else in your head. So my advice would also be, write as many pure functions as possible and where possible. Because if you're not writing pure functions, you can have unexpected behavior anywhere, and therefore also many bugs. But side effects can't be prevented. There also have to happen something somewhere, like updating a database or sending a message, calling a web server. But when you look at these things, you might notice something, especially when you think about hexagonal architecture, that most of these things, most of these side effects happen at the edge of your application, not in the domain logic. In your domain, you can use a lot of pure functions. And there's a concept from functional programming which might help you even inside your business logic to keep it as pure as possible, which is called functional core imperative shell, which I find really interesting. So you might be wanting to look this up later. The idea behind this is that inside your business logic, the majority of the code is pure functions. But when you have to interact with something else, you put that in the imperative shell. So you have a big circle of functional core and a layer around that of imperative shell which handles all the side effects. So for instance, for testing in the functional core, you don't need any mocks. And for the imperative shell, you don't have a lot mocking, not a lot logic. That's mainly in the functional core. So when you have to do some mocking, it's not a big test or something. It's just a small part. And here also the direction of dependencies is inward. So the functional core doesn't depend on the imperative shell. All right, bounded context. I'm going to tell you a story about for the bounded context to give you a bit of a grasp of what it is. If you think about an IT consultancy company, they have some code and they use one model for everything. So one big model for the whole business. But yeah, that doesn't go well very often. So at one moment, a bug appeared. And the cause of that bug was that different groups have different views of reality, different views on that model. Okay, to elaborate on that, there's an employee, which is something in the model throughout the whole consultancy. And an employee exists of a project it's working on, a rate, a level, an IBAN and an address to get their salary, and some completed trainings and ambitions. But what happened was that the rate of that employee was null during the calculation of end-of-year's bonuses. Okay, how can that happen? Well, if you look at the employee, every department has their own view of that employee. And if you think about it this way, you can think about persons like an accountant or a CEO. Do they have a rate? Well, probably your CEO is not working as a consultant for other companies, so he probably doesn't have a rate. So if you want to calculate his end-of-year bonus, it isn't possible. So what is happening here is that you see that there are different departments and they have a different view on the employee. And when you have one big domain model, you have to consider everything in the business when you're reasoning about an employee. So the idea in domain-driven design is that you need multiple models. There are different problems you want to solve in your business, and those different problems need different models to solve it as good as possible. And that is where the bounded context comes in. It is a boundary within your domain where a particular domain model applies. And this is language-driven. So you can see, for instance, with the employee, that for paying the salaries, you call it probably an employee. But if you're working for a client, you're a consultant. So you already see that there's a change in language, and this might guide you that, okay, maybe this also a different problem we are solving here. And the bounded context can be seen as a natural way to split up your model and split up your systems. And it's also often used when you are introducing microservices. So if you have to split up a big system, you can use the bounded context as a way to guide you. And if you have your separate model, then everything inside that model has a ubiquitous language and is strictly consistent. And you don't have to think about everything outside that model. So what you see here is that every department has a different view on the employee, but HR doesn't even think about employees. They probably think about candidates that can turn into employees. So here it's also obvious that HR has a whole different view on the employee thing than the other ones. Okay, that was a lot of theory, but what does this mean for the code? When the company tried to divide the code in subdomains, finance, people management, sales, they ended up with a piece of the code in a shared package. If you see this as microservices, you can see this as a shared library, for instance, with a bank account, an employee, and an employee repository. And yeah, this is where it conflicts a bit, because if you want to be able to decouple those subdomains, so finance and people management and sales, you don't want that shared package because you are coupled through the shared package. But if you move the shared packages and you copy it to all different parts, you have duplication. And that's something that is against the nature of programmers. We don't want duplication. It feels a bit odd to copy-paste it. So that's a trade-off you get into. And how does that work? So it's the balance between don't repeat yourself, dry, and coupling across bounded contexts. How does that work? You can't have both. How I see it is that dry is very important inside a bounded context, but that reduced coupling is more important across bounded contexts. And why is that? Why is that so important? Well, if you have reduced coupling across bounded contexts, across microservices maybe, you have autonomy. You are able to evolve alone. If you decide you have to change your model a bit, you don't have to think about everything else in the organization. You also have decreased cognitive load for the same reason. You only have to think about your own bounded context. And this is especially valuable if your bounded context equals a theme. So as a team, you don't want to be coupled to other teams. If you want to deliver some value, you don't want to be going to another team, hey, we need you, you have to build this for us, otherwise we can't continue. So the decreased coupling is very important in that part as well, and Team Topologies is a great book about that topic, if you didn't know it already. Okay, so what does that mean for the code? We are removing the shared module, and we are duplicating things on the right. So you see in the finance part, we have an employee, in the people management as well, but in sales, we are now able to not add an employee, but call it a consultant, for instance, which matches that domain better. And now we can ask ourselves questions which are easily answered, like, is the CEO an employee or a consultant? If you think about the ubiquitous language, such questions can only be answered within a domain. So for finance, yeah, of course the CEO is an employee, he gets paid. In sales, is the CEO a consultant? Probably not. We're probably not putting him on projects for clients of us. In people management, it may depend on the company. Does he follow courses, or is there something like an ambition map for him? That could be, could not be, but that you see that it's very straightforward now to answer this question, while during the bug, it was very vague. So if you want some help with finding bounded context, I suggest you take a look into event storming. That could be a great technique for finding your bounded context. Also look at language, look at people who are using your software. That can really help you to find out what are the bounded contexts in your situation. And that made us come to the end. What are the next steps now? How can I write code like this? And what I wanted to emphasize on is that you don't write this code from the start. Refactoring is a very important thing. Also, when I mentioned value objects, it is something you evolve into. It's an iterative process. You can just start at any time. And Uncle Bob had a great quote about this in his clean code book. I don't write clean code from the start. I don't think anyone could. So just take baby steps. Another one, and that's more for a personal value, the moment that your code works is when you start investing in your career. So if you think about TDD, about the red-green refactor, The refactor part is where you learn the most, where you have to think about how do I make this code clean, how make it perfect, and not only have to think about how do I hack this into the system so that it works. So personally, I look at this stage as something as investing in my career. I can get better in something. So just take your time for that. And of course, practice makes perfect. So there are great techniques like coding dojos and katas. You can make time in your team to just do a practice assignment and to practice one of the things that I mentioned. For instance, can we refactor a piece into using tell, don't ask a lot? Or can we search for bounded context within our company? Just take an hour and do that, and you can learn from each other. And I think that's very valuable to do that next to your work as well. And hopefully your company supports it as well, and you can then do it on company time. That's even better. Yeah, and now we're close to the end. So this was it. Thanks a lot.